In this video, I will be going to explain you RunnableLambda. Using RunnableLambda, you can convert any Python function into a runnable. So what is the advantage of converting a Python function into a runnable? So the advantage is that if you do this, you can connect that function with other runnables to form a chain. Let me give you one example. For example, you want to print an article on a topic, so you have created a template for which you want to generate an article, and then you pass this template to LLM, and then it will be going to generate you the result which you send to parser to get the actual text. And after that, you see, you also want to do the word count of the article. You do not want to rely on the LLM for the word count of an article because sometimes LLM give wrong results. So what you want to do, you are using parallel chain here, and in one case you are doing runnable pass-through because you want the article as it is, whatever the output this parser will return, that you want to display as it is. And in the another case, what I will do, I will create a function by myself which is a word count function, and in that function I will count the words of this article. But I cannot fix this word count function into this chain because this chain is runnable. I have already told you in the chain only runnables can be connected, not a normal function. So this is a normal function, so it is not a runnable. So this normal function cannot be connected in this particular chain. So what I have to do, I have to make this function as runnable. So to make this function word count as runnable, what I have to do, I have to put it inside RunnableLambda, and I will put word count here. So here I will write here RunnableLambda and word count. So this function will be converted into a runnable with the help of RunnableLambda. And now it can fit into the chain because it's now a runnable. Now this article output I can pass to this word count, and word count will return me the number of words present in the article. So this is the significance of RunnableLambda. So before showing you this complete practical, first I will show you smaller portion that how to create this function and how to put it inside a RunnableLambda. So first I will be going to show you only this particular portion, and then in the next video I will be going to show you the full chain. So here I am creating RunnableLambda 1.py, and here I am importing RunnableLambda which is under LangChain_code.runnables. So I import RunnableLambda class. After this, I am creating a function which is, let's say, word count function, and here I need some input. Let's say x is the input which will be in the form of string. Now I will do x dot split. So what will happen? Suppose you pass a string in x. Let's say my name is Vikas. If I pass this string to x, then what I did x dot split. So when I do x dot split, it will create a list of words. So the words will be my, comma, name, comma, is, comma, Vikas. So a list will be created. Then what I will do, I will do the len function here. So what len function will do, it will give me the length of this list. So there are 4 elements inside the list, so it will return me 4 as an output. So x dot split, what it will do, it will break this string into a list, and then length will count the elements inside the list. So what I will do now, I will use the length function. So it will return me an integer number. So it is saying also it will return you an integer number. So what I do, I will just put return here. So this is a very small function which I have written, and what I will do, I will convert it into runnable. So to convert this function into a runnable, what I will do, I will use RunnableLambda, and I will pass the name of the function here. That's it. So this function has become a runnable. So I'm equating it with an object which is converted runnable. Now this is a runnable, so I can use the invoke function. So I will do converted runnable dot invoke, and you see I will be going to pass my name is Vikas Munja. So this is what I pass here, and I will get the output. So I will get the output in a variable, let's say count, and after that I will be going to print this count. So if I execute it, so it has returned me 5. Now if you have a good experience with Python, then you know that if any function has a single expression and it returns something, so that kind of function can be converted into lambda function. So here if you see, this is only one single expression. It is not multiple expressions I have written. This is only a single expression I have written, and it is returning integer. So this particular function is the perfect candidate to convert it into a lambda function. So I don't need to define this function like this. What I can do here, I can define the function within here. That's it. So I don't need to write these 2 lines of code. I will use the lambda function instead of writing this function. So how to write the lambda function, that I will be going to tell you. And why I am writing the lambda function? Because it is a single expression and it is returning something. So both the rules are satisfied of this function. So that is why I am converting into lambda function. So very simple. What you have to do, you don't need to write def word count. Okay, you don't need to write the name of the function. Instead, what you need to write, you need to just write lambda. That's it. So instead of this def word count, you just need to write lambda. Then you have to write the argument here. So only x is the argument here. So you just write it. Then put colon. And then you don't need to write the return. You just need to write the expression, because it is obvious that lambda will return something. So you don't need to write the return keyword. Just write the single expression which you have. That's it. Now you don't need to write this line of code. You have converted this function into the lambda function. So I don't need this. So I am just commenting it out, and instead I am using this, and it will be going to give me the same result, and my rest of the code will remain the same. So this function is converted to a runnable. Just put this into a runnable lambda. So this is the runnable object now, and you know, if the object is runnable, I can use the invoke function because I have standardized this function, and I am just calling this function, and it will return me the count. So if I run this, so you see still I am getting the 5 as an output. Let's say I put hi here and I run it again. Now it will give me 6. So the code is working fine. So I told you that I will be going to create a template that will be going to ask about an article on some topic. Then this template will be passed to LLM. LLM will generate the article. Then it will be passed to the parser. After this, you see I will use runnable parallel. Here in one of the branches, I will use runnable pass through and show the article as it is. But in the another case, I will use RunnableLambda, and in that I will be going to pass the word count function. So this RunnableLambda will give me the number of words present in the article, and this will return me the article, and here it will return me the count. So this is what I will be going to show you practically. So I already have written initial script where the model which I will be going to use is GPT 3.5 Turbo, and the parser will be string output parser, and the classes I have already imported including the prompt template. So now what I will do, first I will be going to import classes which are present in LangChain underscore core.runnable. So here I will write from LangChain underscore core dot runnables. I will do import runnable lambda. I need runnable parallel. I need runnable pass through. So all the three runnables I need. First I will be going to create a template, and the template will be equal to prompt template, and I will write template is equal to give me an article not more than 150 words about a topic. So here I will be going to write a topic, and then I will be going to write the input variable, and the input variables will be topic. So this is my prompt which is created. Then you see I will be going to create this particular chain. First write template, then separated by a pipe symbol, then LLM, then I will be going to write the parser. So this is my sequential chain which is ready. So I will call it as sequential chain is equal to this. Okay, that's fine. After this, I have to create parallel chain. So here I will be going to use the runnable parallel, and in runnable parallel I will be going to use the dictionary, and within dictionary in the first scenario I will be going to get the article, and here I will be going to use runnable pass through. That's it. So whatever the input I will get, I will just display as it is without any modification. And in the second scenario I will use count keyword, and it will be going to count the number of words. So here I will be going to use the runnable lambda, and within runnable lambda I will be going to use the lambda function. So I will just say lambda x, and I will be going to return the length of all the words. So inside it I will write x dot split. So you see this lambda function I have already explained you. If you are not comfortable with this, then what you can do, you can just create a function and just pass the name of the function inside it. So I have created a parallel chain where I have created both the branches, and I will call it as parallel underscore chain. So you see my both the chains are ready. Now what I have to do, I have to combine this chain and combine the above chain. So both the chains should be combined. So what I will do, I will be going to create a final chain. So in the final chain I will be going to write sequential chain, and that will be combined with the parallel chain. That's it. So now you see I can invoke this particular final chain. So here I will write final chain dot invoke, and when invoke I will use the dictionary, and in that I will be going to pass the name of the variable. So here the name of the variable is topic, and I will write a topic, let's say future jobs in AI. So this is the topic which I have written, and you see it will be going to give me the result, and I will be going to print that result. So I will be going to write print result. Actually, I will show article separately and the count separately. So first I will display the result as article, and then I will print the count, which will tell me the number of words which are present in the article. So here I can write print article, and also I will make one more print statement. Here I will say total words of this article. That's it. So I have completely written the code. So if you notice, first I created this particular chain, which is template, LLM and parser. That will be the input to the runnable parallel, because that is a sequential chain. The sequential chain output will be the input to the parallel chain. So one will be as it is result, and another one will count the number of characters. So I just run this. So here you see this is the article which I have got, and you see these are the total number of words. So if you have a chain and you want to add a custom logic inside the chain, then you can take the help of runnable lambda.